And what I'm going to do is basically find the radius of convergence. So find convergence of the power series sigma -1 to the power n x minus 1 to the power 2n divided by 2n n factorial 1 factorial squared. Okay, all right, so when you look at this, it makes kind of sense that you might want to use the ratio test for this, right? Okay, so let's try to use ratio test. You can even use the root test, right? Okay, so let's take an is equal to -1 to the power n x minus 1 to the power 2n divided by 2n n factorial squared. Then if you do that, you get an plus 1 is equal to -1 to the power n plus 1 x minus 1 to the power 2 of n plus 1 and 2 of n plus 1, and we have n plus 1 factorial squared, right? Let me simplify this a little bit. I'm going to simplify -1 to the power n plus 1 as -1 to the power n times -1, because eventually I want to cancel this off with the an. So x minus 1 to the power 2n plus 2, I'm going to simplify as 2n times x minus 1, because 2n plus 2 times n plus 1 is the same as 2n plus 2. So that can be broken up into 2n and 2. Okay, and I'm going to break up the bottom also as 2n and 2, because 2 to the plus 1. And then this one I'm going to write as n plus 1 factorial is the same as n plus 1 times n factorial, and they are both squared. Okay, so that looks a little better, right? Okay, but more simplified. So now I'm ready to take an plus 1 over an, this quotient. Okay, and absolute value. So I'm going to take absolute value -1 to the power n -1 x minus, I will go and remove the negatives a little later, right? But for the time being, to x to the, I'm just rewriting what's there, and x minus 1 to squared. Okay, divided by, we have 2n times 2, and we have n plus 1 times n factorial squared, right? That is n plus 1. And you want to divide by an, so you're really multiplying by the flip of an, right? That's easier to think of it that way. So the flip of an would be 2n n factorial squared divided by -1 to the power n x minus 1 to the power 2n, because I'm actually dividing by this, but that will be saying as multiplying by the flip of this, right? Okay, and I'm writing that just to make it easier. So let's see what we cancels off, right? So you can see the -1 to the power n cancels off, -1 to the power n cancels off, 2n cancels off, 2n cancels off, x minus 1 to the 2n will cancel off, x minus 1 to the power 2n will cancel off. Okay, so n factorial squared will cancel off n factorial. That's the advantage of actually simplifying it earlier. Okay, so I have -1 here, right? Left. Let's write that down. And x minus 1 squared will be left from the top. And then I have 2 from the bottom. And I have n plus 1 left from the bottom. Take the absolute value of that. Well, you take the absolute value of that, the negative goes off, right? Okay, and basically you have x minus 1 squared over uh, 2 times n plus 1, but the x minus 1 will have an absolute value sign. So I'm just removing the absolute value. Okay. So now consider the limit of this. That's the same as the limit of absolute value of 1 squared over 2 times n plus 1. And if you take out a 1 half, and then you can take out the x minus 1 absolute value sign, you have to find the limit of 1 over n plus 1. And this is 0. So what happens is it drags the whole thing into 0. So the answer is actually 0. With all this effort, right, the answer just turns out to be 0, which is great, which is less than 1. And then regardless of x, right? Okay, so what happens is we can say that limit an plus 1 over an is 0, less than 1, regardless of x. That means converges to all x, the power series, right? Okay, for all x. So what can say is that the radius of convergence is infinity. The interval of convergence, of course, is negative infinity to positive infinity, all real numbers. All right, so that's it for this video. We will see you in another video. Okay.